Good morning, good afternoon, and good evening, depending on where in the world you're joining us from. Welcome to our expert panel, Trusting AI in Production, Building Observability for AI Agents at Scale, brought to you by our friends at Monte Carlo. I'm Jenna Holland, Director of Marketing and Digital here at Data Science Connect, the world's largest data and AI ecosystem for enterprise leaders. Today, we're excited to welcome hundreds of attendees from around the world to explore one of the most critical challenges in enterprise AI, building the observability, reliability, and trust needed to operate AI agents confidently at scale. We're honored to hear from two distinguished experts today. Sam Mittal, VP of AI Solutions, Global Director of ISV Applications, AI Startups, and SaaS at Snowflake, and Ethan Post, Principal FTE, Agent Observability at Monte Carlo. And they'll explore what it actually takes to operate agentic AI systems with confidence. We'll look at how leading teams are using native telemetry alongside production monitoring to catch problems early, maintain reliability at scale, and build the kind of trust in their AI system that lets them move faster over time. Before we begin, a few housekeeping items. To make this feel a little more in person, we suggest you add a photo to your profile and include your bio, LinkedIn profile, and other information you want your fellow attendees to see. Next, please take advantage of the Q&A and chat features in the right sidebar. We'll be addressing your questions throughout the webinar, likely at the end, and be sure to upvote the questions that you'd like the panel to address. If you're wondering where your organization stands compared to others on your AI journey, check out the poll questions in the right sidebar, and we'll be bringing them up on the screen during the presentation as well. And finally, to learn more about how to build reliable, observable, and production-ready AI agent systems at scale, check out the call to action below throughout the webinar to try out Monte Carlo for yourself. Now, without further ado, here are Ethan and Sam to kick it off.
Thanks, Jenna. Wonderful. Thanks for having us. Really excited for a great presentation today. So we'll take roughly the next hour to dive deep into some of the content and the comments that you just made. Give me 1 sec to pull things up here. And as I do, I'll just reiterate the fact that today is intended to be a bit of a back and forth. So the Monte Carlo team is proud to welcome Sam from the Snowflake team in what's going to be a joint presentation. And the primary goal for today, as Jenna had just mentioned, is to really explore this concept of trusted agents in production, exploring the difference between an agent in pre-production or development phase and what it means to actually instill trust in production grade and production level applications. That said, I am proud to say, as Jenna just mentioned, I'm Ethan Post. I'm the principal forward deployed engineer for agent observability at Monte Carlo. Very happy to be joined today by Sam Mittal from Snowflake, who is the VP of AI Solutions, the Global Director of ISV Applications for AI, Startups, and SaaS. So Sam and myself will be exploring in depth around not only how Monte Carlo provides observability for solutions in production, more importantly, how Monte Carlo and Snowflake work together to build a cohesive and unified solution. We're actually going to kick things off really quickly with a poll just to get a sense of who we're speaking with and what level of, I'd say, and not necessarily sophistication, but maturity we have in actually rolling out production grade AI products. So if you will, feel free to answer the poll that had just shown up. So the real question here is, how familiar are you with Snowflake Cortex or Snowflake Intelligence? Because the beginning of this presentation is really going to focus on what Sam will describe as the Snowflake ecosystem, Cortex, Snowflake Intelligence, and other tooling to allow teams to scalably and quickly start to build production grade applications. So we'd love just some feedback on how deep and how in depth we can go on that particular topic. With that said, I'd love to hand the reins over to Sam, who's now going to dive into a little bit of the Snowflake architecture and ecosystem around building AI applications.
Awesome. Thank you, Ethan. I'm Sam Mittal, and I lead strategic partnerships and startups that are primarily playing in the AI ecosystem at Snowflake. Today, I want to share how Snowflake approaches AI and specifically why trust and observability are first-class principles, not afterthoughts. So let's jump in. AI is delivering real results. Fanatics, 2 billion daily signals across 100 million fan profiles. AstraZeneca, 85% reduction in clinical trial protocol authoring. TS Imagine, around 30% cost reduction, 4,000 hours saved, agents deployed in just 1 week. Nissan, mind-boggling 97% sentiment accuracy. These are production systems, not POCs. not demos. The question for everyone in this audience is, how do you get here? And more importantly, how do you stay there? Because production AI that works on Monday can silently degrade by Thursday. The reality is sobering. 30% of the AI projects abandoned due to hallucinations. 95% fail to deliver ROI because they are siloed. 88% cannot scale due to fragmentation. And three patterns I see consistently as I work with the customers and partners. Teams build a great POC with ChatGPT or an open model. It works in the demo. They push to production and it fails. The question is why? Because the POC doesn't need governance. It doesn't need data freshness. It doesn't need monitoring, but your production does. The common thread across all these failure modes, they all stem from a disconnect between your data layer and the AI layer. The model doesn't know the data changed. The team doesn't know that the model is drifting. And nobody knows until the customer complains. Organizations that succeed with AI share three pillars. At the bottom, you have the data foundation, all data in one place, governed, fresh, not scattered across multitude of tools. The middle, business logic and context. The AI understands your roles, your metrics, your terminology, not generic internet knowledge. And on the top, you have AI in every workflow, not just in one team, but embedded within your business. So your business is AI enabled. And let me show you how. This is the Snowflake Data Cloud platform. And in the interest of time, I won't go deep into it, but this is the engine that powers this three pillar framework that I just described. Snowflake keeps everything together: data, compute, models, governance in one governed perimeter. That is what makes enterprise AI possible. And we have quick proof points. Over 13,000 customers um, trust Snowflake. Around 100 of the Forbes Global 2000. 90, around 9,000 plus customers and growing use AI every day. It's in 51 cloud regions across different hyperscalers, recognized by all the different leading firms, Forrester, Gartner, IDC. So this is not experimental. This is enterprise grade AI at global scale. And at Snowflake, the suite of AI features is we call Cortex AI, which is easy, connected, and trusted. So if I parse out these architecture, at the bottom, you see the context. All your data connected in one place. Snowflake tables, Iceberg, OpenFlow connectors, MCP integrations, and business knowledge through semantic views. This is what grounds agents in your actual business truth rather than generic internet knowledge. In the middle, you have decision intelligence. Cortex agents orchestrate across multiple capabilities. Cortex search for unstructured document retrieval, Cortex analyst for text to SQL, the structured data, AI functions for sentiment, extraction, classification. The agent plans, reasons, reflects, and calls the tools. It's a multi-step process and a reasoning system, not a single LLM call. And on the right side is where you have the governance, guardrails, evaluations, monitoring, the cost governance. This includes TrueLens, which Snowflake acquired for native evaluation scoring like groundedness, relevance, toxicity, all scored within the platform, plus Cortex Guard for runtime content safety, and native AI observability that logs every agent span, tool call, and token count automatically. That is the full stack. The context makes the agent smart, decision intelligent makes them capable, and governance makes them trustworthy.
Yeah, and maybe this is the first place, Sam, where I might interject a little bit just to get your thoughts on one, I think, prevailing question, which is of the customers you have, and you talk about the 9,000 plus customers that are in production leveraging Snowflake for AI use cases. What is the alternative? Because it strikes me that Snowflake, as in a universal platform that has open connectivity to all the things you're describing, and the fact that it is a combined data and AI fabric, the idea that you can build agents that serve your business or even external stakeholders from one place. What is the alternative? Because I see a lot of folks building AI and building AI products, but it tends to get highly complex when we're talking about a heterogeneous ecosystem versus what you're describing here.
Yeah, and that's a great question. Actually, there is always this experimentation, and then there is this production, right? If if I have like just a fewer systems, very simple use case, as I can do simply on my desktop. But if you are trying to bring different data modalities, structured data, unstructured data from the multitude of different systems, there is always this data pipeline that's running to keep the content latest and greatest. Then, um, then there is also the business that's changing within your ecosystem that you need to be updated on. There are different kinds of business rules that your enterprise needs
Mm.
that are very specific to you. When you think of all these complexity, and I can keep on going, it becomes like a hairy ball very soon. So the question becomes like, do you want to build the AI that you can trust, or you just want to build the AI which just answers or just have an opinion? Because in general, like opinions, like people, everyone can have the opinion, like AI can have the opinion, but with the business you need more uh, trustworthy and deterministic output, and which is only possible when you have the right people accessing the right data at the right time with the right systems as the substrate of this whole architecture.
Yeah, very well said. And for the record, I mean, of our combined customer base, that's exactly what I'm seeing. So you have customers who have been curating and adding to the Snowflake data model for years or quite some time. And I think now they're able to take advantage of all that hard work and sweat equity in building applications that then become kind of the cornerstone for how they're actually interacting with data on a day-to-day.
Awesome. Great to hear. Yeah, so now we talk about these principles, right? So when we were designing the Cortex agents that you may have heard of, I haven't seen the poll results, but if you have been in the Snowflake ecosystem for a while, um, you have heard of Cortex agents. And when we designed Cortex agents for production, we had 6 principles, right? At the heart of it is the data, right? How you can have right people access the right data, that's implemented through role-based access control. So if your role can't see a column, neither can your agent, right? So no shadow access. The second is accurate context retrieval. So Cortex search for unstructured data and Cortex analyst for text to SQL or structured data. So right retrieval for the right data type. The third is the intelligent orchestration and memory, right? So the agent plans routing across the tools, reflecting on the output, maintaining the memory across the turns. And this goes back to like the complexity of what Ethan was also talking about, right? The alternative, right? Bringing all these things together. Then the powerful tools, right? Um, the web search, code generation, charts, custom libraries, and obviously the SQL functions. And interoperable interfaces, something both inbound and outbound. So you can call the external tools, the external MCP servers, and you can also call into Snowflake through the Snowflake managed MCP server. And what is most relevant for today's conversation is the last one: trust, observability, and governance. So, the governed access, native observability through AI observability events, guardrails via Cortex Guard, and evaluations via TrueLens. Building an agent is probably the easy part. Now, if you have tried Cortex Code, it's just two prompts, but making sure it does the right thing in production at scale over time, that is the hard part. And that brings us to the next slide, the life cycle.
Yeah, so Sam, I actually would invite us to probably co-present on this, because I think the underlying theme here is that nearly everything you just referred to in terms of the tooling and the ecosystem, a lot of teams are thinking about this from the perspective of a developer. And I think it's because AI in many senses is in a fairly nascent state. I think a lot of large enterprises are still early on in their ability to take an idea from idea conception to build through production and actually rounding out this kind of cyclic process. So the thing that strikes the Monte Carlo team, having worked and spoken to hundreds of customers about this exact problem, is most of the life cycle of an agent happens after launch, but most teams are squarely in the mode of considering how do we develop and set up frameworks and do the steps on the left here. So I can certainly speak to these concepts at a high level, but Sam, if you have anything to add on what you're seeing from your customers on the dev side, what I hope to speak to, for the majority of the rest of this conversation is, how do we productionalize this thing? What is the
Yeah.
biggest barrier to getting production grade value?
No, that's a good point, Ethan. So let me parse it out for the audience, right? These 5 stages, and then Ethan, probably you can jump in and parse out more the last two.
Mhm.
So in the first stage, basically, you are designing your prompts, setting up the retrieval, scoring the agent outputs against the evaluation data sets. You are iterating, testing, and all refining in Snowflake. Then comes a red team where you do the adversarial testing. Can the agent be tricked? You are stress testing the guardrails and access controls before going live. And then you ship. So first production traffic, agent is live. This is the starting line, not the finish line. Snowflake provides a platform for all the 3 stages. Now, once you are in production, this is where the 2 new challenges emerge, right? So operate. Things drift, cost creep, data goes stale upstream, behavior changes in ways that are invisible unless you are watching continuously. Snowflake provides the observability foundation. Every span, every tool call is logged natively. But the question is, how do you operationalize that telemetry at scale? And then last but not the least is earning the trust. You can only iterate fast and ship improvements confidently if you can see what's actually happening across your entire fleet. Continuous visibility is what turns agents from experiments into the systems your business can rely on. And these are the last 2 stages: operate and earn trust, where Snowflake native telemetry becomes the foundation for something more. And that's exactly what Ethan is going to walk you through, how that observability data can turn into production grade monitoring, anomaly detection, and incident management. With that, Ethan, over to you.
Very, very well said. Frankly, couldn't have said it better myself, so I'm glad I pulled you in on that. But look, the reality is, I think teams have a bit of a consistent framework for how to do the first 3 steps. And I think what teams are struggling with is how to operationalize the actual productionalization and the value gathering of an agent in the wild in production. And the tagline I'll use is, production grade applications need to handle production grade variability. And that just isn't the case for most teams today. So what I'll do is pull up a second poll here, and really the basis of this question is, how do teams think about productionalizing AI products? So you'll find that there is a pretty even distribution of organizations that are kind of across the spectrum of just exploring, doing some light development and experimentation, prepping for production rollout. And then obviously there's no shortage of organizations in the wild that are doing production grade AI. I think the leading thesis for Monte Carlo is that production grade AI can certainly be streamlined and simplified with the use of a dedicated monitoring and observability tool. So I believe we have a poll that we can either pull up, or I think we may be able to just access on the side. So the question is, where are you with your AI agents? So either in production, in pilot, planning, or not started yet. And the one thing I will say is, as I talk to many teams every single week, and almost start off every conversation with this question, there's no shame in being anywhere along the spectrum. I think the reality is that for most organizations, it takes some intellectual honesty to admit here's where we are and here's where we're going. And I think the biggest risk that organizations run in this particular life cycle is assuming you're further along than you should be, or proposing to be or purporting to be further along than you are, and skipping steps. So if we transition from the poll, what I'll start to do is share a little bit about Monte Carlo's perspective on what is the underlying problem. I think Sam definitely hit the nail on the head in a lack of dedicated tooling and lack of visibility. Monte Carlo commissioned a study recently across 300 plus data and AI executives, and the findings were pretty stark, to be honest. I don't think there's going to be no surprise of anyone who studied AI and that knowing organizations are failing in doing this. But the numbers here, I think, are pretty apparent. So the big one that jumps out is roughly a third of engineering teams are actually confident that they have visibility into what these agents are doing. Obviously, building non-deterministic systems invites some amount of variability, but the fact that the teams who are building these systems themselves don't really have a good handle on predictability towards how they behave, that's a really big deal. Alongside that, you have folks like engineers, AI engineers, software engineers saying, hey, the context quality or the quality of the data that feeds into these things tends to be the biggest barrier or the biggest constraint we're fighting. And 47% have discovered that their agent is essentially accessing things they shouldn't be, right? So those are just some rough numbers that kind of speak to the underlying problem, which is we don't necessarily know what it's doing. And we've ourselves found several instances of agents misbehaving or performing in ways we hadn't expected. So this leads to that diagram and that graph on the right. How are agent issues today discovered? Based upon our findings, this is extremely clear. The way that agent issues are discovered in the wild today is, number one, over half the time, your customers find them. So they're leveraging an agent, they're getting a response and saying, hey, this thing doesn't look right. And when I say customers, these might be external, these may be internal, but these are the users of the systems we're building. Another roughly 40% of the time, these things are caught manually, meaning I have maybe some rough testing, but I'm pretty reliant on eyes on glass or teams that are going in and doing some rough spot checking. There's a little bit of a systematic approach here, but there's always a manual component to the way that teams are doing this at scale. And then 8% of the time, these things are caught, proactively and they're able to be handled. I think everyone in the room would agree 8% is nowhere near enough, especially in a world where agents have oftentimes the autonomy to make business critical decisions and act agentically in a way that can be extremely detrimental. So what is the underlying thesis for Monte Carlo in relation to how we solve this? It's, hey, I need to be agent aware, meaning I need to be able to understand what the agent's doing. And to Sam's point earlier, the telemetry or the agent behavior that's being stored in something like a Snowflake platform, critical to understanding whether that thing is actually working. But on either side of this, it's, well, if I have the correct context and I understand the data, is the data itself accurate? Is it valid? Is it timely? Is it fresh? And on the right side, measuring the actual output quality itself helps teams understand, is it producing what it should? And is this agent that I've designed actually behaving in a way that I can predict and forecast?
I have one question, Ethan, here.
Sure.
So from the Snowflake perspective, the data layer that everything Snowflake manages, the tables, the pipeline, the freshness. So if an upstream table hasn't refreshed in 48 hours, the agent will confidently be giving the stale answers. So how quickly does Monte Carlo typically detects that kind of um, freshness um, relative to when the agent would have agent would be giving a bad answer probably?
It's a great question, and I think that is the true nature of this better together story that you and I are telling here, which is if Monte Carlo has access to the pipelines and the vast set of data that's feeding the context for an agent, the reality is we can typically detect those things not only proactively but at the source of incident, right? Meaning if there is an ingestion problem or some freshness issue or some data quality issue that's been introduced to your data, Monte Carlo is purpose built to detect those things, typically within the order of like 5 to 10 minutes after the fact. So the idea is rather than waiting for data to hydrate downstream and populate the things that are feeding your agents, essentially we can tell you that those things exist right away. And it's going to feel in about 5 minutes that Sam just teed up the demo that I'm going to do in the most perfect way. I promise he's only seen part of it, but exactly what you just described is the exact scenario we're going to dissect in a live product demonstration here.
Awesome. That's music to the ears.
Yeah. Okay, so let's kind of dissect this. Actually, I'll go up one slide, because when we talk about data agent and output, the only addition that I would add in what I call the anatomy of the trust framework for a data is splitting out that agent into two separate pieces. So when we talk about an agent, oftentimes we're looking at things like performance, but also we can look at things like behavior. So from the top down, let's imagine any tool has just identified that there is some issue in agent output. This could be user detected, this could be system detected. Step number one is, hey, something happened. The answer that I just got, or the response that I got to some prompt, doesn't look right. So if you work your way down this list, or what I call the anatomy of that trust framework, well, I can identify that the output's wrong. The next step is, let's go to the behavior. Did the agent do what it was supposed to? And when I say do what it was supposed to, this means, did it call the right tools? Did it issue the correct LLM calls against the correct models? Did it do things in the right order so that I have the context in a window that I can use for decision making? If that looks okay, then let's go to performance. I may have seen things like increased latency or increased error rates that lead to particular tool calls not working as expected. And then the final piece here is the data context. There's an explicit call out that most tools stop after level 3, and frankly, many tools stop after level 1. But the idea is, if I can't go all the way down to the data and understand the health and quality of the thing that's underpinning this whole system, I can only go so deep, right? I still stay relatively surface level. So the demonstration we're going to walk through in a couple minutes here is relative to this idea of these 4 layers of that anatomy of the trust framework. And this is a really, really critical kind of framework to hone in on. So with that said, let's kind of deep dive into each of those 4 layers. So when we talk about output, this is our ability to score or monitor whether the output from a particular agentic process is happening as expected. So here, this diagram is really uncovering, say, maybe I'm measuring something like the groundedness of a particular set of templates or workflows or tasks. And in this case, Monte Carlo may have detected something like a 2-point dip or deviation in this one particular template called FAQ router, right? So the idea is, hey, not only can I tell you whether your response is fit for purpose, but I can identify exactly which response within a sea of responses is the culprit. And why this matters is, if you're doing evaluations, the ability to be quite granular and say, hey, I have a number of metrics or dimensions I want to measure by, and I can segment those metrics and dimensions by the actual behavior exhibited in an agent. This is critical, right? My ability to say, hey, the answer looks wrong, and it looks wrong because of this, and explain that output. This is the first step towards actually instilling trust, which is, I as a system can identify these things before a user has to look at it and use their own intuition to determine whether or not this thing makes sense. Number 2, if you recall back to that diagram, is behavior. Behavior, I think, is often overlooked. I think anyone that's built an agent inherently understands the idea of skills and tools and LLM calls. What Monte Carlo specializes in is understanding the typical behavior that an agent might exhibit, and then solving for scenarios where these things happen unexpectedly. So this particular scenario is, let's imagine I have a tool call called Snowflake SQL. I'm going to go run a SQL query against my particular warehouse, get a response back. In this case, I retried this tool call twice after it's successfully executed. So the downside is, well, hey, I'm taking more time to produce a good response, right? For a 2-second agent execution, it took about 1.2 seconds for this thing to run when it shouldn't have. The other piece is, well, I may be potentially exhausting more tokens. I may just have a bad user experience. Not understanding this concept of tool calls leaves you somewhat blind in order to determine, did the thing do what it was supposed to? The third piece I'll dive into is performance. I'd say this is an area that nearly everyone on this call should be somewhat familiar with. Performance meaning, is the thing performing as it should, from dimensions like error rates, tool calls, time to first token, token utilization, right? So this is an example where Monte Carlo can track things like token utilization over time and identify when I see an anomalous spike in token utilization or token consumption. The idea being, well, hey, this can actually relate to any number of issues, right? Maybe I'm exercising more tokens because I have more usage, which could be good. In this case, we're saying, hey, a potential issue could be, I've changed the retrieval, or in the newest version of this agent, I'm no longer doing a top 5, I'm doing a top 25, meaning the amount of tokens that I'm actually utilizing to get that answer could probably be optimized. So this is both potentially a leading indicator of where you're seeing agent failures, but also a potential for optimization in just the way that a particular agent operates.
This is very interesting insight, and if I may chime in, Ethan,
Mhm.
for a quick sec, because from a cost governance perspective, on the Snowflake side, we have credit monitoring and resource monitors, but those operate at the warehouse level, not the agent level. So you would see your Cortex bill go up, but you wouldn't know which is agent caused it and why. So, Ethan, in that deployment, is that like deployment correlation, something what you showed can be set up automatically, or does it require like the manual deployment or tagging? How does it work out?
Yeah, so there is a flavor of this that is, I'll call it like agnostic or ignorant to the dev lifecycle, meaning all we're really doing is monitoring the traces and the telemetry that's spun off from an agent. And we can in many ways investigate and hypothesize that, hey, I'm noticing you're now using a new model, or the way that this thing behaves is different than it did yesterday. Thus, I can't tell you that it's a new version, but I can tell you that it's directly related to this change in behavior that I'm noticing. The other piece is, how do we take in that rich context you're describing? So if you're actually doing true annotation as part of your CI process, and you have explainability on the changes that are being made, it does make it easy to triangulate on the diffs or the deltas from one version to another. So the reality is, it's not necessary, but it does provide additional context for us to take into account, especially when troubleshooting an issue that we detect.
Got it. And this is, I think, very important as you keep on experimenting and then you see like a new model being deployed. um, you have enough data points to hypothesize and then explore why something happened, right, on diagnosing what part.
Mhm.
uh,
That's
it's cool.
that's exactly right. And that's another area we're going to hit here pretty heavily on the demo piece, because oftentimes when we think about what is the health of my agent, or is it producing high quality, we focus on this concept of detection or monitoring, when in reality, what happens after the fact, right? The operational process of taking that signal and doing something with it, I would say that
Mhm.
is uncharted territory for nearly every organization on the planet. Okay. Last component or last pillar to this process that I really want to touch base on, and then we're actually going to show a live product demonstration. Data context honestly might be the most important piece. I think, again, our leading hypothesis here is, if you don't have good data, you're never going to have good agents. And the idea is, especially in conjunction with Snowflake, we're able to do things like what's shown here. So, hey, in a particular agentic process, or an agent is defined to do something, well, I can have an allow list of tools, or an allow list of data context that can be accessed. But as some of our research pointed to earlier, it's not uncommon for a dev or engineering team to say, oh, this agent is accessing or running queries against something that it shouldn't even know exists, or it shouldn't be, right? So the idea is, if I can tell you the exact context that's pulled into the execution of an agent, I can also validate that that's what it should have done, which is, again, simple enough to say, quite hard to do in the wild. So I do want to switch gears real quick, Sam, unless there was anything else you wanted to talk through on the presentation side to show
Uh,
a little bit of this. Obviously, we'll only be able to kind of touch the surface, but what are your thoughts?
No, I'll say go for it. Just one last piece on the security, because that's very at the heart of Snowflake. What you touch on, like RBAC, which I talked about, is a prevention mechanism, but what you
Mhm.
showed is a detection mechanism, right? Like what actually happens when the agents are operating in practice. How can you detect, like in the eventuality, what agents are accessing, so you can see like if there are any anomalies. So it's like kind of a very complementary and kind of like almost, I say, security chocolate peanut butter combo.
That's a really good point. And I think that is one of several scenarios I can think of. So when you think about security, you have detection or monitoring that can say, hey, this thing accessed something it shouldn't have, or did something it shouldn't have. This should then inform the development process to say, hey, on the next iteration of building, maybe I need to tighten up the RBAC, or maybe I need to actually more tightly control those tools. Same thing would be something like guardrails, right? So you may have set up a set of guardrails. Come to find out, maybe those guardrails don't actually suffice for the entire surface area of what can happen. So this is a cyclic process in which, when you detect something, yes, I need to fix it, but I probably also need to build resiliency back into the system itself.
Awesome.
All right, so let's kind of take a look at how Monte Carlo and Snowflake work together. Thought it would be kind of fun to actually start this demonstration or this live presentation from Snowflake itself. So if you're not seeing, or if you've not seen this before, I would strongly advise you to check it out. This is actually a Snowflake intelligence agent that is built on that Cortex framework that Sam had discussed. So I have an agent here. You might not be able to see it. It's called my branch sales reporter. One of the most common use cases folks will roll out first off, which is, hey, I have sales data. Let's build an agent so folks can understand sales. So I'll just choose one of the pre-populated questions here. And the question is, what were my top 5 best performing branches over the last month? Pretty straightforward answer. And because Snowflake provides me the ability to build semantic views and predefine, metrics and definitions, it works very, very consistently, as well as pretty efficiently, right? So you'll notice in 2 to 3 seconds, I got a response back that answers my question directly. It's, hey, here are my top 5 performing branches last month. You'll notice I'm listing 5 branches. I have things like revenue, invoice volume, and average invoice amount. This looks like the exact answer that I would expect, right? Also, I see things like key insights. So not only am I relying on the output itself, this is pretty good at also telling me why or where. So East Bay is the region that's best performing. I see volume-driven performances because my invoice amount's roughly the same, but I have deviations in volume. This is all really good. The other thing that Snowflake allows me to do is ask follow-up questions. So in a very conversational way, I can then say, hey, are there any branches with data feed issues or stale data? You probably see where this is going in that I got a pretty clear answer to this question that should inform me of what I should then go do. But unless I ask the question of, hey, is the data that I just used good, right? Is it of high quality? Is it fresh? Is it up to date? You'll see here in a second, not to bury the lead, but it's not, right? The reality is there could be underlying issues with this data that I only know as a consumer unless I ask this question, unless I have some detection or monitoring capability on top. So you see Snowflake is currently ripping through a number of queries and trying to gain context. Turns out there's some significant data freshness concerns, and no branch has received new data since mid-April. So you gave me an answer, and that's the right answer based upon what's there. But I'm now blind to the fact that there's several things that sit out here. For in fact, I think there's one branch here, my Richmond branch. I haven't gotten data since October 3rd, right? Maybe that's a true business outcome. Maybe I closed this branch and there's some reason for that. But what users of these agentic systems and these agent outputs are typically blind to is, well, what is the context? What is the semantics? And how can I trust the answer that's being given? So again, what I will acknowledge is the output that I just showed you is a product of me potentially having designed a bad system. But for most organizations that are just rolling this out for the first time, there needs to be a hand-holding period or an ability to kind of learn along the way. But the one thing that users are not going to sit back and wait for is, hey, I'll give you guys a month or 2 to get things together. It's if I'm going to use this thing, it better work. So if I cut over to Monte Carlo, let's take a look at that same agent. So in Monte Carlo, I've registered that branch sales agent inside of the Monte Carlo platform. And the really cool thing about the way that this works is Snowflake, on every interaction that a consumer has with that particular agent, is logging that trace data or that telemetry in a table. So Monte Carlo reads that table and says, okay, well, I can pull out some operational metrics. So in this case, I see things like trace count, latency, token utilization. These are those high-level operational metrics that oftentimes are leading indicators of poor behavior. So the good news is, just upon seeing this trace data, Monte Carlo was applying machine learning-based detection on these things to be able to say, hey, your traces are going up, or you're seeing an increased latency over the past several days. That might be something to look into. So there is some operational coverage on the way that this thing works. More importantly, or certainly more interestingly, Monte Carlo is also aware of those traces. So for example, if I look at any of these records that actually make up the way that users are interacting with that system, I can actually pull up a record that represents the exact conversation I just had. So if you look at this particular trace, essentially what I'm doing is, from top to bottom, this is the series of steps that was just taking place. So while it seems straightforward enough for me to ask a question and get an answer, what actually happens is I say, hey, what were my top 5 best performing branches? Snowflake then says, hey, here's what the user's asking for. Go issue some tool calls, run some other spans within this process, and eventually spit out that answer, right? So this is the series of steps that was taken. Now in Monte Carlo, there's a couple of critical features. Number one, I can see this thing live. Yeah. Go ahead, Sam.
Yeah, before you go further, I just want to make sure for audience benefit, can you confirm this, all of this data is reading Snowflake's native tables, right? System tables, no additional instrumentation or no SDK to install, no data leaving the account. I want people to understand there is a zero friction setup here.
Yeah, that's exactly right. So there is no need to store your data anywhere within Monte Carlo. I am reading this live, and the benefit is exactly as you described. There's nothing to install. There's nothing to configure. All we do is read from that system table and essentially treat it after the fact in a way that is fit for monitoring and observability.
Awesome.
So what I'm left with is not only an understanding of what happened, I even have something like a neat AI summary of, hey, these are all the things that occurred as part of this, and here's the output. The other thing that Monte Carlo does is stitches these things together. So if you're new to this concept of how agents behave, there's this concept of multiple turns or a conversation. So if you look at what I actually did within the Snowflake platform, I asked a question and then I got an answer. And then I asked another question and I got another answer. So the value of Monte Carlo sitting on top of this is I can stitch these things together and understand this is one user interaction. But maybe more importantly, I can understand everything else that happened. So for example, here are some of the queries that were generated. Here's the context that came back. And what this provides me is the ability to not just say, hey, was the answer good or not? It's, hey, was the process in getting that answer valid? And did you do the things that I expect? So as you can expect, thinking about this at enterprise scale with hundreds or thousands of users, I might be able to go in and on a one-off be able to say, hey, for this example, did the agent do what it was supposed to? But if we zoom out and also take into account the idea that that context that I just talked through is gathered through a series of ingestions and transformations and curations. So Monte Carlo not just monitors the agent, but also looks at the entire pipeline that feeds into that agent. So what I'm showing here is a series of steps or things that feed into the data that I'm showing. And I can also highlight, hey, I have a particular portion of this pipeline, my invoice pipeline, which looks like it's had some recent issues, right? So I've had 4 alerts in the last week on this particular table. So as Sam and I were discussing earlier, I probably could have told you you're going to have issues with this agent well before anyone went in. And in fact, on April 13th, when I stopped getting data, I got a notification in Monte Carlo that said, hey, you know, your data feed stopped or your data has a freshness issue that's still not been resolved. So the idea is, yes, I can monitor the agent, but more importantly, I can monitor the whole system end to end. Now, here's where things get very tricky, because when you think about the complexity that goes into building these things at enterprise scale, it's very difficult for a human to come in and say, oh, here are the 5 monitors I need in order to make sure that this thing is operating at enterprise scale and operating reliably. So what Monte Carlo is designed is not just the ability to see and do these things. More importantly, this gets kind of meta, so it feels like sometimes I'm in the movie Inception, but we have an agentic layer that sits on top of this set of capabilities to guide user experience. So we have a set of agents that I can deploy against this or any other use case. And earlier today, I actually pre-populated this just as an example, rather than me going in and trying to identify the evaluations or the monitors or the things that I need to go validate. What I actually can do is say, hey, Monte Carlo, you know more about this agent than me at this point based upon all the things you've seen. Help me monitor this agent. Now, obviously, I can manually do these things as well. But as a first pass, what Monte Carlo does is goes and reads a bunch of the trace and telemetry data, potentially reads data from some of those upstream objects and says, okay, here are the 5 things I think you need just as baseline coverage. Now, again, in a very conversational way, I can follow this up. And in this case, I said, okay, well, maybe I built this agent and I know a little bit more about it. So help me understand additional applications for evaluations, meaning how do I measure the effectiveness of the output, and help me ensure that the responses given contain up-to-date data, as we saw earlier, or numbers that actually make logical sense given the state and status of my business. So Monte Carlo then again can go back and understand some of the source data, run some queries against the telemetry, and really deeply get some understanding and opinionation around what this agent does. So you'll notice I'm not coming back and saying, okay, this agent has 6 branches in context. I see roughly invoice amounts from $0 to $1,400, and I'm trying to right size this and just understand what makes sense and what's normal. So based upon those facts, Monte Carlo can come back and say, okay, you need to do 2 things. Make sure that the data is not stale. In this case, it is. Make sure that I don't see weird capacity utilization. This is a metric in this thing, and I've seen 34 million% utilization. Crazy, right? Maybe a human would never be able to see that, but because I have this agentic layer, I can come in and start to ask questions and interrogate that agent. The other thing I find really interesting is tool calls and trajectory and the agent behavior. So really quickly, I'll touch upon this because this is an area that for even the folks who have built these agents, there's not a lot of understanding of what they're actually doing in the wild in many cases. So I then followed that up and said, hey, help me understand what this thing normally does when it executes. And Monte Carlo drew me essentially this mermaid diagram or this depiction of, well, here's the flow or the series of events. And additionally, I think you need these monitors that look for conditions that tell me that the agent's not behaving. So make sure it analyzes the correct amount of branches, make sure that I understand the distribution of the amount of invoices I might see, right? So again, the idea is providing that agentic layer on top of what Monte Carlo can just allow you to manually build gives you this concept of getting to trust and getting to scale quickly versus folks toiling away at something that hopefully a machine can aid. Last thing I wanted to show really quickly, and then we're going to dive back into some lessons learned, is what happens after the fact. So let's imagine you've stood up an agent, you've used Monte Carlo to deploy monitoring, and now you're looking at all the things you should to be able to answer the question, is my agent working? Well, in Monte Carlo, it doesn't stop there, right? The idea is I also can give you this concept of live real-time alerting. So this is an example of an evaluation. Again, an evaluation is a measurement of the output across some dimension. Now, Monte Carlo is evaluating my agent and saying, okay, I'm looking at this thing called adherence score. Essentially, did the output actually answer the prompt in the way that it was supposed to? And you'll notice that for as long as this thing has been running, it's been a 5 out of 5. So we score this thing numerically from 1 to 5. And you'll notice this is actually a real production issue where on May 5th, that number dropped to 1, right? So I'm seeing a massive degradation all of a sudden in the way that this thing performs in adherence to prompt. Now, this is a signal that something's happened and the output is degrading. What Monte Carlo allows me to do is come in and say, hey, that's great. Show me that specific example. So this is a specific example where my adherence score is a 1 because I have this input or system prompt and I have this output, right? We also can explain this, and Monte Carlo is very clearly saying, hey, the instructions specify the output should include a reason and a name in this case, and the output doesn't give any of these, right? So I very clearly said, well, the prompt is telling me to do this and the output should look like this. And if it doesn't, I can measure this and tell you that something's wrong. The most important part of this process, though, is actually triangulating the thing that broke, which is the hardest part. So Monte Carlo, again, offers this agentic layer on top to be able to say, hey, troubleshoot this for me. Look at everything you know about this agent and you tell me what's wrong. So we hypothesized through hundreds of scenarios to try to determine what happened exactly at this time to make this particular trace different than the rest. And it turns out there's a tool call called create validation rules. That's just the name of the tool call. And I've seen some intermittent errors and timeouts. And it looks like this is driven by some upstream LLM call and it's been compounded by some weird system outage. So it explains very clearly what happened that led to this degradation in output. So number one, I can identify this for you and alert you in real time in whatever channel you want. Number two, I can tell you what happened and give you very clear next steps on what you should do to fix the problem versus basically just being a smoke detector and saying, hey, your agent's not performing. Good luck going to figure that out. Because as we've learned today, hopefully, there's a lot of complexity that goes into the way that these things operate. And if you don't have a control plane or a layer on top, you're essentially going to spend more time troubleshooting and fixing things than you spend developing and productionalizing your products. Okay, roughly 10 minutes left. What I wanted to do really quickly is just talk through some lessons learned or some actionable next steps for folks, whether you're using Monte Carlo or not. Here are the things that I would recommend you start to think about in terms of early warnings or things that you should be looking at in terms of your agent development. So really quickly, I'll just list them off. Obviously, we'll share the recording and the materials afterwards. Retry rate. This means, do I have a step in this process that is consistently kicking off or retrying when it shouldn't be? Eval scores, as we just saw, seeing a dramatic drop or a dip in the performance or the output quality. Trace depth blowout, meaning if I'm looking at things like how many traces are actually being called or what is the actual call depth for a particular execution of that agent. Token run. So this really refers to things like how many tokens are being utilized, how many can I predict and forecast, and is it more or less? First scene resource access. This essentially describes, am I seeing behavior and going to fetch data or try to get agent context that it shouldn't? And then finally, customer tickets. So I think there's going to be some world in which we're still reliant on customer feedback, whether this is thumbs up or thumbs down, or actual ticket creation, and your ability to take that ticket, link it back to agent behavior and performance, and be able to say, hey, yeah, this was an issue, but it's fixed, or this is a new issue and I can investigate. Those are kind of the 6 takeaways that hopefully teams can take away and not only build in your processes, but really consider as you're trying to productionalize some of these systems. Sam, anything you'd add here before I have a couple quick calls to action that I'd love to open it up? I know we have some questions coming through on the platform.
No, I actually didn't have this full picture of the demo, so I was glad to see this in action. Like we were talking about all the things, especially on the last 2 fronts. Like we talk about building and shipping, but then how do you operate at scale and you keep on having the trust in the system, especially with the agents that you're running. So yeah, it's always this thing, right? How are you not just building it, but also optimizing? So to
Mhm.
your earlier point, that more time should go in the business outcomes and not really doing the plumbing and fixing the system. But in the case there are anomalies, how quickly you can figure out what and why is really the velocity that can drive the real outcomes for the business.
Very, very well said. And I think that that's true both on the value realization piece and also just time to value. So points well received. Okay. So again, the tagline here is that the teams that are moving the fastest aren't taking more risks. They're the ones with tighter feedback loops and also an expectation and understanding of all the things that may break and a solution for either closing those gaps or having that monitoring capability. And again, the idea is Snowflake is the source. Monte Carlo is the additive capabilities to monitor, predict, and build quality and outputs on top of that. Okay, if you'll be headed to Snowflake Summit next month, quick call out that Monte Carlo will also be there. So from June 1st to 4th in San Francisco at the Moscone Center, you'll notice that not only will we have a booth 1313, we also have some speaker events. So on Monday and Wednesday, we have 3 speaker engagements from our customers speaking through how they're actually doing this in the wild. So hopefully you take my word for it, but if you don't and you'll be in San Francisco on those days, we'd love to see you there. Feel free to register and I'd love to see some friendly faces. Last call out or last plug for Snowflake Summit is, in addition to those conversations I just mentioned, Monte Carlo also will be hosting what we call our Cafe AI, which is outside of the Moscone Center. We actually will be serving up not just trusted AI, but also coffee, pastries, donuts, things to get your day started the right way. So if we don't see it at the summit, if we don't see it at those conversations, we'd love to at least see you stop by and maybe enjoy a nice coffee on us. All right, sped through a lot of that, but hopefully this was informative, it was helpful, and also it was engaging. I'd love to turn over to the Q&A because I know I saw a number of questions coming through. Sam, I can monitor those, and maybe what I'll do is tee up the ones that we'll have time for. Any other questions that we don't get to, maybe we'll send responses to as a follow-up. Let's do this. Okay. So let's chat through some of these questions. I'll actually start from the bottom up. So which part of this trust framework do most enterprises struggle with implementing most and why? Sam, do you have any thoughts on that? I do have some pretty distinct thoughts, just selling this for a living and speaking with folks who are doing this in the wild. What are your thoughts?
I think I'll have you go first and I'll chime in, but yeah, let's go that way.
Yeah, to me, it's all data and context, right? The thing that organizations struggle with is typically this cross-system visibility on, hey, I can monitor something about my agent and I might have some data quality understanding. I don't have these 2 things linked together. So it's hyper critical to think about not just data quality, but context quality in relation to what the agent's actually doing.
Yeah, I think I always look at the business outcome because in my world, every system or architecture is a science experiment if it is not tied to a business outcome. And what business is looking is how we can get the ROI and the TCO and reduce the TCO. And in that, trust plays a big role, right? With these systems, how fast not only you are building, but how fast you are able to keep them up to date and make sure your users for which the system is designed and for the answers they are driving, you have high fidelity in them.
Yeah. Well said. And I think I really appreciate the focus in bringing it back to value and ROI, because none of this means anything if it's just an experimentation. The intent is to do something with this that is beneficial to any enterprise. Okay, the next one, and working our way up. This is a pretty interesting one. Sam, I'll let you speak to this first, and then I'll share some of my thoughts or findings. So once a customer is building a workflow with a specific set of models, do they stay with those models to avoid their prompts and context breaking in the future? Or I guess the subtext is, do they switch those things in favor of the latest and greatest?
Yeah, and that's like a $1 million question, right? Because you always have these specific model that you started with, but I always say we are in an unprecedented uh, this revolution where even a 1 week feels like months or years sometimes, right? With the changes coming in. Um, However, my philosophy and my suggestion to the customers has been, um, when you start with a business problem, right? Ultimately, model is a means to an end, right? But going back to the same conversation of driving the business outcome, I will always see how much is the model giving me, like P90, P95 performance, and is the new model which I'm say thinking about, is it because of just because it has more capabilities uh, for what I'm trying to do later on, or it may increase my efficacy for the current thing, right? um, because when you are trying to switch the model, there is this whole the downstream effect, because the things you have optimized for something, you just don't want to um, uh, you know um, disrupt just for the sake of it, but anchoring into these key KPIs that you started with, the working on the model, the business problem, and what is the acceptable drift in those KPIs or tolerance that you have, is should be the determining factor.
Yeah, I think that's exactly right. In my experience in working with customers that are doing this, I think there's probably two things to acknowledge. So number one is like building for the sake of like building things that are future proof. A lot of organizations are doing things like standing up like scaffolding or agent harnesses to do dev testing, right? So a really common workflow would be something like, hey, I have ground truth evaluations or golden record scoring, and I'm able to say, if I change the model, what impact does it actually have to my prompts or my context or what have you? So I would advise no one in the wild is just like flippantly changing models because Anthropic just released the latest yesterday. It's these things need to be thoroughly tested and vetted and understand what those changes might be. The other thing I will acknowledge is that's not foolproof. So the value of Monte Carlo on top of that specifically is I've seen many examples in the wild where we see things like a dip in performance on an output. And given that troubleshooting agent I showed earlier, a really common root cause that we'll sometimes see is, hey, yesterday you were using Claude Haiku 4.5 and you just upgraded to Opus, and now all of a sudden the output looks worse, right? You hopefully would catch that in dev, but part of the purpose of having a tool like Monte Carlo is so you don't build things scared of breaking things down the line, right? I think that's my perspective.
Yeah, well said. And I think also this not one size fits all, right? We have always seen these model all built on the transformer architecture, right? Going nitty gritty a little bit, but they all have the different frameworks, right? So that's also important to know. Like some are great in the deep research, like for example, the Anthropic models are deep on the research, but if you need more, the language and more on the analysis, then the ChatGPT models or OpenAI models are better, right? So there is also this evaluation in general. But then, as Ethan said, experimentation is part of this process as the things are evolving. So how do you know what is breaking, and then figuring out why is paramount.
Very well said. And unfortunately, that takes us not just to time, but past time. I know there were a couple questions left, so what we'll try to do is answer those in a follow-up. But again, appreciate everyone joining, and hopefully this is informative for the team.
Thanks, Sam and Ethan.
Yep. Thank you, everyone.
Thank you all for joining us today. Great insights from Ethan and Sam. If you missed any of the webinar or want to re-watch anything, the recording will be available a few minutes after the webinar if you refresh this page. Thank you again to our partners at Monte Carlo. We'll see you next time.